Plan calcul. This is the first high-level language. This guy, Conrad Zeus, was a genius, but very underappreciated. You got John von Neumann, very famous. The church, of course. I wonder what happens. Let me shutting this thing. Could this be the core? Quit. Goodbye. Okay. Programming language between 42 and 45. First high-level programming language to be designed for a computer. High-level language from the 1940s. Epic. German computer pioneer, the Z4. (1948). For a long time to come, programming a computer would only be thought of as programming with machine code. The first compiler was implemented in 98. Epic. No go-to construct. No types, assignments, conditionals. There we go. There you go. You got a ternary. So you could do anything with that. Good description of the syntax can be found here. Boo! It's not there. Well, let's go to the home page. Conrad Zeus, Internet Archive. In the encyclopedia. Assembly line self-replicating systems. Boolean algebra, relays, electromechanics. Let's have a look at the Z4. Z3, 32-bit, 22-bit floating point. What a genius. Something is very wrong with my computer. So let's try shutting down a bunch of other things. This backup D helper, I'll turn that off. Open the time machine preferences, I'll just turn it off. Backup automatically, turn that off for now. Options. Cancel that. Okay, leave that open so that I can remember to turn it back on later. What else could I possibly turn off? Let's have a look. Let's turn this off. What's this? This? Get rid of this. Quit. This thing. Go away. Docker. Let's quit Docker. But it should be able to run Docker. Shouldn't be a problem. I quit this thing. Quit this. Quit out of this IntelliJ thing. Hello. This IntelliJ. Quit. What else can I quit? Let's quit out of this. Gosh, it's like using a computer from the 90s. And this is like a modern MacBook with 32 gigs of RAM in it. It should not act like this. It's practically unusable. Memory pressure. No. Okay, let's quit out of this. Quit. Some of the connections are mounted, they'll be unmounted. Yeah, that's cool. That's pretty much all the little things. Okay, so yeah, I'm gonna dip into the Z3. But I want to see a program written in this language, Britannica. ResearchGate. Let's have a look. This has got to be it. Read full text. All right, here we go. Syntax, variables, yeah. What does a program look like? Guarded commands. Wow. Syntax directed editor. Computationally universal. Front end. Run the chess playing programs. This guy's epic. Let me find his chess playing program. Here we go. Yes. 1945, he wrote a chess playing program. It's in German. Okay. He wrote a chess playing program in 1945. He wrote a language. This guy's a gangster. Let's go forward again. Nah, no good. Resources. The compiler. Let's have a look at the editor. Okay, manuscripts, computing machines. Yeah, right, the self-replicating. Advanced manufacturing concept he envisioned in 57. Electromechanical automation of manufacturing processes to implement customized building projects. Universal factory. It's like 3D printing. And it can print its own plant like more advanced printers. The Ferranti Mark 1 Z4. Expect American computers, the Z4 44. So the Z3. So the Z3 was electromechanical. Used relays. So, okay, so yeah, let's go to the EDVAC and then we'll do a flashback. Okay, so we'll do... Yeah, okay, let's get the Z3. Did we open that one? This is historycomputer.com. And this one, different one. Planned calculus. Okay, chess. Let's have a look. Chess program. I want to see this. Is my camera frozen over here? See if I can unfreeze it. Camera. Switch to that one. Switch back to that one. I think I have to unplug my camera and replug it in. Camera. Include in switcher. It's kind of weird. FaceTime. HD Pro. Camera's frozen. Interesting. Anyway, I'm going to unplug it and see if that fixes it. Have you tried turning it off and turning it back on again? Okay. Yep, that fixed it. Okay. Let's have a look. The first high level, blah, blah, blah. Not just a chess playing program. No. Here we go. Okay. Oh. Okay, so extensively component. Yeah, relays, yeah. Dyadic. Logistics maths. Propositional calculus, Boole's algebra. Yeah. Z2, the Z3, it's a digital computer. Predicate logic. Oh man, this guy's a genius. Yeah, but I want to see the actual program. Python implementations. Let's have a look. Let's try this. No HTTPS certificate. Bad website. Ja, nein wird. The yes no word. Ja, nein Wörter. Okay, so, oh man, this guy's great. He's using Alonzo Church encoding. Reference context. Concept. Auxiliary procedures for a chess program formulated by Zeus and plan calcul notifications. Come on. This looks like Pascal. Kind of. Oh, it's an Algol 68. Proc R17. Okay, so yeah, he's defined these as subroutines. Advantageous is plural modes and some predominant gets practical weakness. 60s, unorthodox notation, yeah. Disregarded mechanical processing, notational feature, structuring of objects. Structuring of objects. Okay, this is what his programs look like. Syntax checking of Boolean expressions. Coded in bit sequences. Procedures. Far out. So he invented a digital computer that uses Boolean church encoding Boolean calculus. Wow. Okay, let me get a picture of him. Kasparov. Our guy's name is Conrad Zeus. Plan calcul engine. Epic. Wow. Let's have a look at what his program looks like in Python. Total piece value of the board. Interesting. Let's get that picture of Conrad Zeus. Images. Let's get a picture of it with the Z3. Next level, all right. The first digital computer. Incredible. So it uses lambda calculus. I think that's what you call lambda calculus. Lambda calculus. Yeah, okay. So yeah, he was a mathematics teacher. Conrad Zuse was. Let's get a picture of Conrad Zuse, eh? Put him in there. Let's have a look at this. 12 most dangerous hackers of all time. How do I visit the... oh yeah, click on that. $1941. Far out. Okay, so we'll do EDVAC next. Get rid of all the Bitcoin mining stuff. Yeah, okay, EDVAC. So duplicate this. EDVAC. View the file. Oh, that's right. It downloads it. All right. Okay. Replace image. Upload from computer. Downloads. Wow. Group items by date added. Should be at the top. And then I want to look at... oh yeah, there we go. That does it. This one. EDVAC. John von Neumann. So, this was the first fully stored program. Duplicate the slide. So we're going to go back to 19. When did he write this plan calcul thing? He wrote it in his plan calcul. 1943. What a pioneer. Okay, we can close that. Close that one. Plan calcul. Invented in 1945. Okay, but yeah, he had invented this computer in 1941, the Z3. So let's get a picture of the Z3. Save image as. Wow. Workspace. Oof. Presentations, BPMN, why would you even? And this is the Z3. Yeah, cool. Place the image, upload from computer, workspace, Commanda, presentations, BPMN, why would you even, Z3. Bam. Think I can do like, hang on, Control Zeta, yeah. Format options, crop image, reset image. What does that do? Yeah, it's cool. Okay, then scale. Okay, man, this thing is amazing. Okay, so 1949. Okay, so the EDVAC computer. It came out in 1949. It was designed by John von Neumann. And was the first fully, well, hang on. If the Z3 came out and, let's have a look. EDVAC. How do you program the Z3 then? Yeah, it was binary and it was a stored program. Okay, so it's binary rather than decimal. And was a fully stored program. Computer. A von Neumann machine. Which is the modern computer architecture. Classical computer architecture. Okay, well, let's have a look at the Z3. Z3 computer. Programmable, fully automatic digital computer. Epic. 41. Okay, so the Z3, man. Okay, the world's first digital, fully programmable computer. Okay, it was electromechanical. It used relays instead of valves. Written from punched film. Universal Turing Machine, no conditional branch. Boolean algebra. Used 4,000 watts. It's pretty cool. It's pretty small too. It's good. So there's EDVAC, there's EDSAC as well. EDSAC. But this Manchester Baby 1. Let's have a look. Relation to other work. Here we go. Manchester Mark 1 and EDSAC. Okay, subroutines. Dude, they've like invented the subroutine. Let's have a look at this Manchester Mark 1. Amazing. So when did Manchester Mark 1 come out? 48. Okay, so first discussed by Alan Turing in 1936. But von Neumann got the naming rights. One year prior to EDVAC. The Manchester Mark 1 came online. Came online in the UK. But even earlier than that is this. So I think I should put the Mark 1. Okay, it used only 4,000 watts of electricity, 4 kilowatts. The inventor, Konrad Zuse, Plan calcul. Lambda calculus. Due to the war, his research didn't get his research and inventions didn't get much publicity. Okay, so I mean, basically what we invented here was an abstraction of a program. Okay, save the image as Oh. Okay, I'll figure that out in a second. Manchester Mark II. Show me how. Oh yeah, okay, here we go. Copy this. Duplicate the slide, so we're sliding backwards through time now. 1948, Manchester Mark 1. Manchester Mark 1. Replace. Upload from the computer. It says it's the Manchester Mark II, but whatever. Reset image. Good. Okay, shrink it down to fit on the page. And let's put the attribution on the page. Let's put here. And then just shrink it down a little bit. There we go. And let's have a look at this handiwork. Yeah, it's cool. Okay, but then we got the Z3. And then I want to put his duplicate slide. I'm going to put in Conrad. Picture of Conrad. Save image as Zeus. Oh, that was pretty cool, yeah. Just the name. Save image as Conrad Zeus. Comrade Zeus. Dr. Zeus. Actually, very similar names. Wonder if they have a similar etymology. Okay, so we'll put this guy in. Oh. Replace image. Upload from computer. Reset image. Very cool. Okay, and then let's duplicate that slide, and then I want to put in his programming language. Lambda calculus, yeah. Z4. Okay. Let's have a look here. Where's my picture of the... I had a picture. Here we go. That looks cool. Save image as... this is called plan calcul. Plan calcul. Save. Replace image. I'm going to blaze through this. This will be about like 5 minutes of the presentation at the beginning. Place the image. Reset. Image. There we go. Dude, the guy wrote a chess engine. Here we go. Combinatorics of conditionals. Combinatorics, propositional calculus, lattice theory. Wow. (1942). So when did he write Plan Calcul then? Okay, so he started developing it in 1939. Ooh. APL. Arrays and tuples. So he had objects. Wow. Okay, so he didn't get to implement it. Okay, here's the original file. Cool. Yeah, it's coming down. Okay. The ENIAC coding system. ENIAC shortcode, ARC assembly, CPC coding scheme, Haskell Curry notation system. Predecessors, none. 43 in here. Okay, so we'll put it as 43. Shortcode, superplan, intermediate programming language, shortcode, brief code, superplan. Let's have a look. Operator programming. Where's the first one that I recognize? Fortran. Still going. Lisp. Unicode. Never heard of it. Algol 58. Okay, so Algol. APT? No. APL I've heard of. COBOL. Lisp. Algol. COBOL. More Fortran. APL. Simula. Snowball. Heard of it. Don't know much about it. PLI. Heard of it. Basic. Yeah. Know that one. RPG. People are still using that. It's a database programming language. Track. Algol, Fortran, Coral, APL, Simula 67. Yep. Space programming language. 70s. Fourth. Pascal. Yep. Based on Algol 60 and Algol W. Smalltalk. 72. Based on Simula 67. 67. Simula 67. Okay, so we'll give this a date of 43 then. Germany was forbidden to make computers. So Conrad worked on his programming language on paper. Okay, so this is where we say on paper and wrote a chess engine in it. However, without hardware, to run it on, didn't get any traction. Okay, so the first abstraction was like programming itself. You had to invent programming as something separate from hardware. Let's have a look. Where is that Python plan? Python. Here we go. Boom. Let's take a photo of this.
Playing from Josh's MacBook Pro.
Okay. And then we'll grab... Okay, so... Yeah. So, duplicate the slide. If people are interested, they can check this out. So we'll move this up. And we're going to put a link. No, not to that. So I should put some text. Paste it in. Boom. Make it into a link. And here. Come on. Replace image. Upload from the computer. I took a screenshot, so it'll be on my desktop. Pretty sure that's it. Very good. Okay, plan calcul chess engine. (1948). Yeah, cool. I'm liking it. I'm feeling it. I'm feeling it. Amazing. So here because we're going to switch to this next one, which is Conrad Zeus. It's actually, because it's an acronym or an initialism. EDVAC. So we got the Manchester Mark 1 here. Double. Manchester Mark 1. Okay, I'm going to take a break for a little while, I think. One of the things I've been doing is strengthening the back of my shoulders using a stretching band. Otherwise, the front of your chest gets really tight from just programming all the time. Typing, being at the computer. That's great. It feels good. Squeeze the shoulder blades together. Yes. This is going to be epic, man. This is just scratching the surface. Over the last couple of weeks, I've done just like so much kind of like thinking and research about this. This is the first five minutes of an hour-long presentation. I was watching this video by head of communications engineering at MongoDB. He's like, do the code freeze 2 weeks before. I kind of like my presentations to be super fresh. But I think I'll do this one as a conference talk. You know who I'm really inspired by is Dylan Beatty. Love his work. Yeah, great. Yeah, I'm going to take a break and get something to drink. But before I do that, I just want to check on one thing here. And that is that I heard and I saw that Monster Cat bought Silk Records. Madness. Yeah, Monster Cat Silk joins Gold on March 22. Oh man, this is epic. I'm listening to Shingo Nakamura right now. And I got like a, I wrote to Silk Records and said, can I play Shingo Nakamura in my stream? And they're like, sure. But you know, we'll put like a copyright claim on your videos. And with Monster Cat Gold, I can stream Monster Cat tracks in my stream without getting copyright claims. And man, now that Silk Records are on Monster Cat, and it's joining Monster Cat Gold. It means I can stream Shingo Nakamura and Alex H in my stream and not have to worry about copyright claims on the videos. Amazing. So good. Very good. Okay, cool. Congratulations, Monster Cat. Congratulations, Silk Records. Monster Cat Silk. Amazing. Okay, break time. I'll be back.